So I've done attached in different industry, attached to telecom industry, mobiling, attached to US-based company, attached to educational companies. So during this journey, I have done some achievement as well. Like currently, I'm holding almost 25 different IT certifications, a few relevant to different vendors, VMware, AWS, Microsoft, and my journey is keep growing. So, and I recently joined 12 Tech, so this is one of the new journey regarding my career. I'm going to basically do a thing. It's a demonstration as well as a presentation. So I'm going to deploy a 3-tier application using CI/CD pipelining. So let me introduce what I'm going to do. So this is the app infrastructure. Basically contains, it's a 3-tier infrastructure. So the front end and the presentation layer is based on Nginx, where the traffic comes in. And then the second layer is the application layer. The application layer is basically Python. The framework is using Flask-based. So the traffic comes, then it will basically process, and then after process, it will be stored in the database. Database, I used Radius. So, but we can use MySQL and other things as well. So the tools that I use for this demo, it's almost 7 tools. I use Code Editor, where I put the code. I use Visual Studio, as well as the Notepad. The version control system, I use Git. The code repository, I use GitHub. I plan to use GitLab. I want to build entire thing in my laptop, but I have some issues, so I use GitHub. This is the public repository we have. In the CI/CD pipeline, I use software that is called Jenkins, where I basically get the data, perform some processing, and deploy it. I will show you how things are going to work. And the image tool that I use, the Docker, and the image repository, I use Docker Hub. In the future, might be I use Nexus because I have expertise in Nexus as well. And the deployment, I use the Kubernetes cluster. So this is all the tools I use to demonstrate all these technologies. So you can ask any question during this presentation and demonstration. So the Jenkins, I just don't just take one Jenkins system. So I build the entire cluster. So Jenkins usually take requests, perform CI/CD pipeline. So I do basically master-slave architecture. So master just get the traffic, and then forward the traffic to the one of the slave server. And slave server basically do all of these stuff. So I have 2 slave server. One is to get the data from the Git, process it, make an image, and put to the Docker Hub. And the second is basically get the data from the GitHub, process it, and deploy one of the Kubernetes cluster. So this thing is going to happen next. The Kubernetes cluster, again, it's a full-fledged cluster. It's a 3-node cluster. It's built by using kubeadm, and it contains 1 master node and 2 slave nodes. So we have fun for it. GitHub, I have created 3 repositories, 2 for the apps, 1 for the front end, and second was for the application, and 1 for the Kubernetes deployment. Our Docker Hub, 2 images. Again, I will show you. Okay, so this is the entire flow. So I develop my code using Visual Studio. I may push my code to one of the repository, that is GitHub, and then Jenkins job is there. Jenkins job basically grab the data from the GitHub. I have added basically pulling as well. Whenever I change something here, Jenkins job basically pick from the GitHub. I will show you in the demonstration as well. So once that data or the software is grabbed by the Jenkins master, it use one of the slave servers to do basically actual thing. So he pick one of the slave servers. That job is basically get the application, process it, make an image of Docker, and then push one of the Docker Hub repository. So this Jenkins master grab the data, put everything to the slave server. Slave server is basically doing 2 things. First thing is making an application containerized, build an image, and put to the Docker Hub server. Okay, so we have an application that is containerized and that is pushed to the Docker repository as well. Now we need to deploy it. We have a continuous integration. So this part where the data comes from the Visual Studio to the GitHub, and the Jenkins slave picks data and then perform image is called the CI part. And that is continuous because whenever I do anything in the change here, it will do the same thing without any human involvement. Okay, the second part is basically the deployment. So for that, I have one of the repo. I have a deployment file. I mean, Kubernetes, we have a deployment file. That is also the part of GitHub. It get the file. Jenkins take the file, go to one of the slave server. Slave server basically have a session with one of the Kubernetes, that is a Kubernetes master server, and deploy this file. So we have a continuous integration and we have a continuous deployment. So this is the whole process I am going to demonstrate and show you as well. So any question until now?
So is this the standard Jenkins architecture that you need slave? Because, for example, if you talk about code pipeline, there are phases, right? So does we need slaves for each phase of the CI/CD pipeline?
It could be. The master is basically, I mean, usually it's a standard practice because master is just grab the data, don't process it. Because if that master is doing the process, then might be he's busy, CPU cycles are busy, it will not perform the actual thing. So it's just taking the data, okay, and then pick one of the slave server that is available that we decided and put it, okay, this is your task and do it. Then in the stage level, we can do as well. I mean, we can pick further on every stage, okay, pick this slave, process. For example, one Jenkins slave is to take a name, create an image, and second slave is to basically push to the Docker Hub. So we can do it in this way as well. But the main goal is the master part is don't do anything, just control the things. The process and the slave part is basically do the actual thing.
Yes.
Okay, so are those slaves like in sequence, and master is controlling that sequence? I mean, if deployment goes first and it's still in building phase, the other slaves, so how is it being managed?
Okay, when we create, I can show you as well. When we create a basically job in Jenkins, we can pick a slave as well. We can say, okay, these are the slave, or this is the slave that will perform this task. It can be one slave, or it can be any. So in the job, I said, okay, pick this slave and perform it. Again, it can be one slave, or it can be many slaves. Same I do with the same thing as well.
Right. But what my question was is that one slave will complete its job. Once it's done, the master will know that and then trigger the second one. Like the build and deployment would not be in parallel. They would be one after the other.
It can be parallel, it can be sequence. So we can do, everything is done by here in the job side. In the job side, we can do, okay, if the slave job is successful, then do the second thing. Or we can control again here, if the job is not successful, then don't do this again. Okay, so the job is basically we decide, okay, the part is successful, okay, if it's successful, okay, if it's not successful, what the exception we can do, okay. So everything we can control via basically job procedure.
Okay. So my question is, the part of code where we connect the Jenkins to the repository is written in the same repository, right?
Yeah. No. The job is basically I created here, but it can be a file. Okay. For this demonstration, I do two things. I use GUI tool as well as I created scripted as well. So that part, CI part, is basically a GUI based tool where I create a job, pick the slave, and perform, and basically creating an image and do it. That part is using a scripted language. Basically, I create a script in the Jenkins that is performing the part. But that script is not part of GitHub. In the future, I will add in the GitHub as well. So this is the question. Okay. So should I move next? Yes.
Excuse me, can you please use the mic for asking the questions so that the project ID will be used? Thank you.
Normally in our industry, when we use CI/CD, we also use the automated script to test the code before actually getting it deployed in production. So where does it involve in this architecture, this automated script?
Okay, very relevant question. So my code is basically doing CI part without doing any testing. But usually, whenever we do the CI part, the next process is basically send this Docker not to the production direct, just send to the any QA side or the staging side where it will evaluate. If it's perfectly fine, again Jenkins is controlling everything. If the job is done by slave, is perfectly fine. I mean, we evaluate. For example, in Java, we have done a Maven job. We have tested some things. Everything is okay. Then we move towards the CD part. Okay. So in this presentation, only thing is CI/CD without doing any testing. But yes, of course, we can add quality in any stage as well. Because Jenkins job is basically the part of staging. One stage, second stage, third stage, fourth stage. On any stage we can control, it's onto us, in our hand. So again, so this is just a CI/CD without doing any quality assurance. But if we want to add any quality assurance, it will be done right after this. Once the image go to the hub, the second now we will create another job. That part is basically, okay, grab the image, run it, perform some quality assurance, perform some testing. If everything looks okay, then send a signal to Jenkins. Jenkins pick the signal, and either we can go to the production by manual, or we can make it automated as well.
Why one should go for Jenkins if we have like other options like AWS CI/CD pipelines? Is there like any cost optimization or anything specific to Jenkins?
Yeah. So again, we might go to Azure as well. We might go to Google as well. So if we create or made our effort to one thing, for example, AWS have all the things, but it is only relevant to the AWS. But if we deploy this thing, we can use the same tools to deploy or do everything on the Azure as well as the Google Cloud as well. So this is one of the reasons. So this is not only the tools. I mean, many tools, CI/CD tools are there. GitLab itself can do Git action. GitHub have a Git action that is use the CI/CD pipeline as well. But they are all proprietary things. So Jenkins is the open source, so this is one of the reasons I picked this one. And this is the popular as well.
It's basically just another way to build a CI/CD pipeline. I think Jenkins has been around for a very long time. So the ecosystem around Jenkins is much more richer.
Right, yeah, say. Okay.
I think it can be used on local machines as well, where there is no cloud.
Yeah, this is that I have this one as well. Okay, and that is also evolving nowadays. Now the new terms is come that is called GitOps. You might be familiar with this. So now the deployment is not done by Jenkins. In the future presentation, might be we have a virtual presentation, I will try to demonstrate as well how we can use GitOps, that is a modern thing, to deploy the things without using any Ansible or other thing. So GitOps itself is a full-fledged stack where we can get, okay, we have the data, we need to deploy in the one of the Kubernetes cluster, what are the ways, and GitOps is one of the way we can use it in the future as well. Okay, so regarding the application, the 3-tier application, that is a snap pass. You might be familiar with this. For example, if I need to send a password to someone, what is the way? Either can they give direct to you the password, or I can send you a one URL. So you will use this URL. Once you hit this URL, you will consume it. So usually we give the password on some social media sites or some HTTPS sites, and then we forget it. We don't know either this password is used by or not. So this is one of the tools that we can utilize. If someone is used one time, that is expiry date as well. Nobody can go again to the same URL and grab the password. So this is the open source application. We can get it from the Google as well. Okay, so let me show the demonstrate. So any question regarding presentation? Okay, just few things. So here I basically grab application. I didn't develop the application. I grabbed the application basically. So I use this Git Visual Studio Code. Then I have session with one of my Kubernetes cluster. I will show you in the Kubernetes cluster as well. Let me show you a few things. Okay, so instead I show you this one. Okay, so this is the entire, you can see it's a small data center running in my laptop. So this is Jenkins. Currently I'm using one slave, but we can do two slave as well. But this is the master and this is the slave. And this is the Kubernetes cluster that is running one master and two worker nodes. And this is my Docker, basically where I'm creating images and testing as well. This is the entire infrastructure. And if I go here, okay, these are the three jobs. First job is, again, we can, my point is basically usually CI/CD is thinking about it's a one process. But usually now in industry, it's not a one go process. CI part should be separated from the CD part. CI is managing by might be developers, but CD part is totally managed by the operation team. And the reason is, one of the reason we will discuss as well. So my basically have three jobs. One job is basically get the data from the GitHub, processes and store as an image to one of the GitHub. This is the front end, this is the back end job, and this is the Kubernetes job. So let me show you one of the job. For example, this one. If I go to configure, okay, so this is the account where my application is stored. So you ask me which slave. So here I defining this one. My job is basically go this slave. I can add as many as well. Even we can make a cluster as well. For example, this is just a label. In a label we might be in a backend two slave basically. So this is where basically we are okay. This job is go this specific slave. Here in the GitHub, I have three repositories. The front end where the Nginx code is there, the application, the 3-tier application where is Python based Flask infrastructure based code is there, and the third one is Kubernetes where my deployment file is there. If I open any one like this one, so this is the deployment file that we are going to basically deploy. That is the CD part. It's a very big part. So basically it's doing all the things. Okay, so let me connect to the Kubernetes cluster. Okay, so 3 pods are running. Let me remove all these pods. So since it's hosted on my laptop, so resources, due to the resources issue, you will seeing some delay. Otherwise, in a production, it's a very quick job. So if I check my task manager, so almost I'm reaching to memory limitation. CPU is enough, but anyhow. So here nothing is running. So I am going to demonstrate the CD part since we have a time limitation as well. So if I go here, so this is the Kubernetes part where I'm going to deploy. Let me show you what I'm going to do. So again, This is the repository. This is the SCM. If anything I made change, it will basically go to SCM. And goal job is basically Jenkins job is keep checking the GitHub repository. If anything happen, if any change is found, basically trigger this job, and this job will be triggered. Source code management. Okay.
Is this created using a console or the Jenkins file?
Let me show you. Okay, if I click on configure, it is searching. Okay, now. So here it's a full-fledged pipeline script. Okay, so two jobs basically built via GUI. We want to show you. Okay, we can do same thing with the GUI as well as the pipeline build. So this is the full pipeline. So what pipeline is doing here, we have different stages. So in this project, in the deployment project, we have only two stages. So first stage is the checkout. It will basically get the deployment file and check it out. And the second stage is it basically have a session with one of the Kubernetes cluster master node, and it basically execute one of the deployment file. If you see here, it's basically deploying a deployment file. So let me execute it.
What language is this?
The script, it's a Groovy,
Okay.
I think. Okay, I'm going to build it now. If I want to check what's going on in the background, if I go to the console output, so here the code is basically downloading from the Git. Okay, so now that CD part is building. If I show you here, it's a very good graphical representation. You see here, that part is done, and that part is in progress. So now it's completed. So if I go to my Kubernetes cluster, so before it was running nothing. Now if I show there, get pods, so 3 of the pods running, 2 of the apps and 1 of the basically Redis server. Redis is, I think, is currently in progress. Let's wait. It's having some issue. Okay, might be the internet, might be something. Okay, now apps are running, but how can I check it? Let me check. If I go to SVC, so which port is running? It's running 3036. If I open the browser, and if I go here, and if I pick 30366, and my node is 91. This is one of the worker node, and it's using HTTPS protocol. Let me verify again, 30036. Okay, so we have the app now. Okay, so again, the process of app I don't want to show, but the thing is, our entire CI/CD pipeline is working. So any question?
Okay, so how is this architecture feasible for a non-cloud infrastructure? Like it's on your machine, and if we set up 10 machines, right, and how will we handle load balancing, auto scaling? If 5 machines goes down, how will we trigger maybe idle systems up, configure them, and then Kubernetes container up running on them.
Okay, so two separate things. Okay, if I go here, let me open the presentation.
Let's don't discuss editor, it doesn't matter. Version control system, it doesn't matter. Code repository is better, okay, definitely matter. If I use public repository, they will do it by themselves. If I use AWS, AWS code repository is do by itself. I mean, we don't worry about the, how many requests we are sending or how many pull requests we are receiving. They are managing by itself. The CD part is the Jenkins part. So your question is regarding the Jenkins or your question is regarding the Kubernetes? For the Kubernetes, it have different concept. For example, if we go to AWS EKS, so there is basically auto load balancing processes there. For example, if the load comes, we can launch further EC2 instances. Or even within the Kubernetes, there is a concept that is called horizontal port scaling. So whenever the more requests are coming, we can launch more instances again. But in a local data center, that we basically do some scripting. Okay, if the number of requests are reaching there, then launch another instance. For another instance, in this case, a virtual machine, and then attach this machine to the Kubernetes cluster. We can do it very easily. But usually, people deploy that kind of load in the cloud because they don't want to basically keep their cycle busy to do this thing. They want the deployment thing, not basically to keep ourselves or keep the resources busy to add more resources.
So this whole scenario is being managed by a separate service we have, which will make sure that a new VM would be spin up, or we have Kubernetes provide us this.
If this Kubernetes cluster is deployed by ourselves, then we have to manage it by ourselves. Or the question is, how can I manage it?
How can I know the load is increasing? Okay, we will build a script because this is the manual thing. We build data center manually. There is no automated way. Okay, we can make a script that keep checking the resources. Number one, if the resources is lack of CPU memory, okay, spin up another VM. We can make a script very easily. Spin up a VM and part of the cluster. This is one thing. Or we can make a script to keep watch a session. If the sessions are increasing, okay, spin up another VM and attach to the cluster. But if this same thing is running in the cloud, for example, in AWS EKS, they manage it by themselves. They keep watching the same thing that we are doing manually. They have the same thing. They have the script that keep watching the resources, and if this field resources are lacking, okay, spin up another EC2 instance and made part of the cluster.
Any managed solutions with any open source like Red Hat provide us such features that we can deploy a custom cloud on our own VM?
OpenStack is one of the things. OpenStack.
Yeah, I have a very good experience in the past in the OpenStack, but not now. So this is one of the things. They are using the same infrastructure that AWS are using, for example. Or this is the open source, but if you are going to the private mode, then VMware, vCloud, they have their own way. And I think many companies are there that you can build a private cloud in your data center as well. Microsoft itself have a private cloud. They have 8 tools that can be used to build a private cloud. System Center, the brand name is System Center, then configuration management, VM management, and I think 7 or 8 tools they can use to build the entire cloud. So any other question? No? Thank you.
Very good presentation. I think the nice thing about this presentation